that reason, I wanted to become an engineer. I became a eye specialist where engineering is most used in medical science. It's combination of engineering and medicine. I cannot work even a single minute without contribution of you people. I always have one of the equipments in my hand which is designed, invented, monitored, repaired by you people. So thanks to you people for contributing to this medical science. If you see, I think if you see this picture, you have a pointer?
Yes, sir. Yes,
okay. See, around 100, 200, 300 years back, that was the medicine. The surgeries were done in a hall where you can see the system operating there. Now this is a modern equipment operation theatre. You can see the difference. All this is because of the newly invented equipments and which are adopted by medical sciences. This technology and instrumentation has changed in many ways. One, it has changed the way of diagnosis. We are diagnosing the patients early, diagnosing the diseases early, so the suffering is less. Our accuracy of diagnosis become better with the advent of newer imaging technologies, investigation technologies. Even the treatment duration is better, and the success rate has become immensely very high in recent days because of the technology. So technology is equal to engineering. So not only in ophthalmology, because an ophthalmologist I am telling you this, if you see any branch of medicine, technology is invaded everywhere. Even if you go to radio diagnosis, medicine, surgical fields, laboratory, pathology, everywhere there is technological advancement, and every month this is order of the day that changed. We are being added with more equipments day by day. Briefly, this is eye because today I am concentrating on ophthalmology as an eye specialist. So this is eye where it has got from front to back a cornea, which is a transparent layer which refracts the light into the lens. That is the lens where there is also a refracting media. So after being refracted by two medias, by cornea and lens, the image is focused on the retina. So this is how eye works. So this is if you see a flower that is refracted from the cornea and second lens, then that is exactly focused in the retina. So retina is basically a film where it captures the image and sends the image to the optic nerve, which is, you can see a star there, is an optic nerve that connects brain to the eye. So this is how the eye works.
Can you hear me? Okay. So I am very happy that the organizers invited me to deliver a talk. They considered me as one of the resource person, and I am very, very thankful to the principal of the institution, and especially my special thanks to Dr. Badi. And just I want to mention that my association with Badi is very, very long back. We were classmates in from 8th to PUC second year in Gulbarga. And after PUC second year, he switched over to engineering. I moved to BSc, MCA, and we didn't had a contact. And once in 2008, when I was working in Karnataka University, Dharwad, I attended a workshop at IIT Kharagpur, and it was organized by Biomedical Engineering Department at IIT Kharagpur, and there was one resource person called Dr. Manjunath. And just I was interacting with him, and he told that he was from Karnataka itself. He worked in this Bapuji Engineering College, and he mentioned the name of Holi sir, that he was colleague of him. So that's how I came to know that Dr. Holi is working here, and then later we contacted, and now we have association in different ways. We are associated with each other. So today I asked what kind of information, what kind of material I should deliver. He told little bit focus on the research. I think most of you are the aspirants for PhD. Am I correct? Okay. So I will little bit focus on how you can initiate, because there is a great need for good PhD students. Everyone want to do PhD, but none of them want to do work. So this is the very bad principle that is being adopted by the students. And we are in search of good students. We get many students, many people approach us, but getting a good student is very, very difficult. So I will give you a little bit hint which can definitely help you in achieving getting a PhD seat and doing your PhD very, very successful. First thing is you focus on what topic you want to work. That should be very clear. You should be very, very clear on which area you want to work, on which topic you want to work. So there should be a clear focus on topic, and then you must have a deep knowledge in that area. When you focus on that area, you must have a deep knowledge. So getting deep knowledge is through reading a lot. You have to do a lot of survey, you have to do study, you have to refer good papers. Again here many journals are
that part will be taken as a printout and it will be sent. So this is how the recent 3D along with CT, MRI, positron emission techniques, PETs, etc. which are coming. So 4D dynamic CT, the functional MRI, even the functionalities of each and every component is catched, so that you can observe whether really the blood was moving or it is simply the image is showing from one stage to another stage. All these functionalities should also be taken. I think the days will come to add so many times. Next. This is at the macro level and this is micro. Both are interesting. Yesterday I was seeing a doctor. It's very interesting. I got that pathologist, he is an MD doctor. He is having a camera with him, attached with a small focusing unit. I asked why you are attached to this. Sir, the real camera costs to observe any of the inner details of an organism, it was 14 lakhs. JJ Medical College is having one such camera which is placed over it to observe the microorganism at the cell level. So what you are doing in this camera? It was very simple. Then this camera is the ordinary camera with all the whatever is visible. Only what I attached is the focusing concept as an extra quantity. I will keep in the microscope. We cannot take a photo because it will shake and everything. Even a small shake may result in a bad figure. But whereas this tries to give a very correct picture. Observe that picture is so it is almost equivalent to what a camera of that can give. So in this way, the micro level observation at the microscopic level and macro level observation both are an interesting way. The reason for today's is fast. All of you observe, taking the data is so faster, dynamic, farther, 3D anatomy of interest today. What is there on the background? What is there on the front ground? One thing it is clear for me even today, that 3D image construction is still under the process of image construction. It is not with only the camera gives the 2D information. At different angles, whatever you are going to take and club this is still the graphics support. The computer graphics support results in the 3D modulus. The functional physiology of this and fusion. This is the last part which is giving an interesting. You ask now the doctor whether CT image comes, MRI image, both image will be there. but he has to observe what is there inside in each of these literature. When you combine this, you get an interesting image. So that is how the fusion has taken its importance for today's seminar.
Thank you, Santosh, for a nice introduction. In this workshop on advanced in biomedical instrumentation for quality healthcare, I would like to give a presentation on the application of the wireless network, that is wireless body area network for health monitoring. As I mentioned in the introduction, I am working as a professor and in the Department of Telecommunication Engineering at EEES ITW Mysore. In this particular talk, I am going to cover these aspects. What are wireless networks? What is the classification of wireless network, and what is wireless body area network? What are their properties, architecture, protocols used, the technology associated with the body area network, and what are their applications in health monitoring, and some of the research evidence. As you know, previously we were using the wired network. In the case of wired network, the different computing devices can be connected with the help of the wires. And when the devices are connected, when I say computing devices, any device which is having the processor or controller as the processing element. The problem is the help of the wired network is that when you want to expand the network or move the network from one location to another location, the entire setup has to be changed. That's the drawback of the wired network. And in order to overcome that disadvantage, we are going to go for the wireless network. And wireless networks are basically networking of the devices by means of air, by using the radio waves or electromagnetic waves. And even it can be connected with the help of the RF waves also in the case of the line of sight communication. And how these wireless networks can be classified? The wireless network can be classified depending upon the application and signal coverage. Depending upon the range of coverage of the signal, it is classified into
Professor Harish to thanks for the nice introduction. I congratulate first of all for the organizers for having given me an opportunity to share my few thoughts. So I thought, let me speak something about my research area. So before me, there are a few research persons who are already spoken in a similar area. I think there are few topics which might overlap. Of course, it's a research; it's open-ended. There are a lot of opportunities there. I try to avoid those overlapping areas and try to project some of the things which we can carry out. Okay, I just started with a message. A Chinese proverb says, "A picture is worth 1,000 words." For the human beings, it is more true because as a human beings, we try to have more of picturization. We have a better perception, in pictures rather rather watching the textual things. Okay, there is more curiosity if I watch, the video rather looking at the text. That's what the proverb says. As far as the human beings are concerned, it is true. But if you look at the second statement, even a supercomputer would tell, I prefer 1,000 words rather one picture. So it's a very clear distinction. If you look at the statements here, even a supercomputers will really worry to process the image because there is a lot of things which are involved in the image representations. I just take forward this quote. Look at this. Generally, the half portion what we see on top, this is what the human beings are looking at. Okay, as a human being, I try to represent my own way of looking at the things. But in the rest.
Let us say this problem is auditory of potential, auditory disorder, identify that. Assume that if this sophisticated computer cannot do that task, then no human being can do that task. That is the last but one set. That is, there was nothing yet, nothing the brain could do, a well-designed computer could not. If this computer cannot solve some problem or it cannot do something, then no human being can do that. But after 50 years later, now, still these statements are still, people will say, fast computer is there, this thing will get there. If you tell me, in case of this cancer treatment or TB treatment or auditory sensor, this one disorders, then physiotherapy or whatever may be, how many places people are using are successful in standard techniques compared to doctors? Can they replace the doctors? Can they replace the medical experts? To some extent, they can, but they cannot replace it. But since people have to do the research, then they try to explore some of the things. That is soft computing approach, an innovative approach for constructing the computationally intelligent system. I told what is meant by intelligence. It is an emerging approach for computing which parallels the remarkable ability of human mind to reason and learn in an environment of uncertainty and insufficiency. Human beings, there is no problem. There is no one speaking. The people who are in the front row, they can listen. The people who are in the last row, I don't think they are missing anything. They are also listening, right? But assume that you for example, to give input, the earphone has to be in the ear. It should not be. Fan should be off. Earlier I told in some slide that it depends upon environmental conditions, all those things. Doctor can diagnose the patient with a different environment. The same thing. Not necessarily that they have to bring back to the same state. And any complex real world problems require intelligent system that combines knowledge, techniques, methodologies from various sources with the experience, with his past experience in the various patients. Doctor will update himself. Can computer update by itself? So you want to make a AI system, artificial intelligence system, human beings ourselves. We will update, we will learn sometimes from the mistake, from the experience, all those things. Can computer makes in any of these things? Intelligent systems are supposed to possess human-like expertise within the specific domain, adapt themselves and learn to do better in changing environment and explain how they make decisions or take actions. That is, can we build a system, biological diagnosis, a tool, so for example, this auditory disorder checking or any applications like this. There are so many applications. Can we build the tools and techniques which can totally replace the medical experts? It is not possible because experts are experts, but to some extent, people are researchers makes an effort to make the computer intelligent. Human beings are intelligent. We want to make computer also to be intelligent. Why human beings are intelligent? Because we have brain, right? We have brain. We have
it has been possible since last 3 years because of one because of a biomedical engineering student who is working at our SS hospital. His name is Satish. I think today if I am standing in front of our engineering faculty, it's due to one of your students who works day in and day out with all our biomedical equipments. And though he is not here, I would like to thank him. And because of him, I got connected to Sir and to Mr. Nandish and to some of the students at BIT who successfully did a project with us. In fact, it was their concept. And at this outset, I would definitely want to say something. That is, most of the medical equipments, whatever are there today, though they have been invented by Westerners, the recent developments, whatever has occurred, it is due to Indians, those who are not in India. So in fact, the brain behind all these gadgets, whatever is there, if you see me at my ultrasound clinic or at the X-ray center or at the CT or MRI, so most of the top-notch brains who are behind it is one person, somebody who is like you, an Indian. Basically, why is it very much essential today? Because we are saying advances in biomedical instrumentation for quality healthcare. So why are we not able to deliver quality healthcare just like what it happens in US? What is the reason behind it? The reason behind it is cost. And why is it costly? It is just costly because we are not the ones who are inventing things. We are not the ones who are telling the world that this is how it works. If you just take the population, see, I'm going little out of the track because my talk needs to be relevant to everything. See, if you see all the medical literature or medical equipments and you see the population, so most of the population of the world lives in either in China or in India. Okay, so if most of the population is there in India, then why does medical literature is depending upon the Western studies? Have you ever thought if somebody says crocin works for fever? Okay, if there are only 1 lakh people in UK and if there are crores of people in India, how are they able to say that out of only 1 lakh we have studied on 10,000 patients and we say that this is a drug? That's not right. We have the population, we have the brains, but only thing is we don't work together. We don't work together. Really, in fact, if you see any of the literature which is published by foreign countries with regarding to biomedical engineering, right now I'm working with Professor Asha Lata also on some of the project. So, if you see, most of it is with the doctor, with the engineers, and some of them, even some social people are also involved with those things. Why is it important? If you just take a scenario like tuberculosis. Tuberculosis is so common in India, and it is treatable. Still, it has been cause of death and it is cause of suffering for so many of us. What is the reason? A simple rural person has a cough for more than 3 weeks. The basic thing what is required is a chest X-ray. Is it there in the hospitals? In the periphery? It's not there. Why is it not there? Because when they send a quotation for an X-ray machine, the Siemens and GE and so I hope no company people are there. They are the people who will come up with the machines and the quotations. And why are we buying their machines? Though there are Indian companies manufacturing X-ray machines and if you want a digital X-ray, it is again Fuji, Kodak, all these Japanese and those people. Why it should be like that? So that is where it is very crucial for all the teachers who are teaching students, both the medical teachers as well as the engineering teachers, to make sure that you just have to put one, I would say, if you have to tell in very colloquial language, one hula or telel bitbidbekasthe. That they have to do this. In fact, the earlier project
now let me connect the
ECG now. So I am taking the output and monitoring it on the oscilloscope. Relax.
ಮುಂದೆ PQR ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡ್ರಿ. It's coming in form of pulse.
Do the measurement of the heart rate. Just to show the marker on the next QRS. So directly this oscilloscope is giving me the frequency 1.5 Hertz. We convert that into 60, will give his heart rate. 1.5 into 60. 90 beats per minute. So no. Basically, but still probably we can connect it to the low pass filter. It is like you go on building the, adding the blocks and building the system. Every module will have an input and the output. Whatever is the output will go as the input to the next module. So that, so I will switch on the channel 2.
Sure, both.
Yeah. Yes, that's what I am doing. So you have ECG without filter with filter. Now it becomes easy for us to detect the QRS. So by putting a level detector, we will be able to detect the QRS.
So detect QRS compressed
Blue channel 2. So now you will be able to see of the cursor. So with every QRS event, you have a pulse which is getting detected. Now, we don't want our circuit to detect T wave as a QRS and have another pulse being detected. So to avoid that, what we do is we introduce a refractory period, which is nothing but a monostable multivibrator pulse width of around 250 millisecond. So around 200 to 250 millisecond, which is a non-retriggerable monostable multivibrator. So within that period, no other pulse will get detected, and we know that by then the T wave would be passed. So let us see the output of this block, and we'll be able to appreciate this.
So only the QRS R wave and this.
So we have a pulse wherein, if you see the pulse width of this, by then the T wave is actually passed. So you don't have any other pulse getting detected, and the other most important part is now I am going to connect it to it.
ಅಟೆಂಡೆನ್ಸ್
ಕೇಳ್ಬಿಡ್ತೀನಿ ಅವರಿಗೆ.
ಮೇಡಮ್ ಬಂದ್ವಿ.
ಕೇಳು ಅಂತ ಹೇಳಿದ್ರು. ಅರ್ಧ ಡಾಕ್ಟ್ರಿಗೆ ಫೋನ್ ಮಾಡಿದೆ, ಅವ್ರು ಇಷ್ಟ ಇದ್ರೆ ಮಾಡ್ತೀನಿ ನನಗಿದ್ರೆ ಮಾಡಿದ್ರೆ, ಇಲ್ಲ ಮಾಡಿಸೋದಕ್ಕಾಗಲ್ಲ ಒಂದು ಮೈಂಡ್ ಅವ್ರ ರಿಸ್ಕ್ ಇರುತ್ತೆ. ಹೆಂಗೆ ಕೊಡ್ತಾರೆ? ಚೆನ್ನಾಗಿ ಕೊಡ್ತಾರೆ? ಚೆನ್ನಾಗಿ ಕೊಡ್ತಾರೆ.
ಲೈಟ್ ಇಲ್ಲಿಂದ ಬರ್ತೇನೆ
ಅಲ್ಲ ನಮ್ದು ತೆಗೀರಿ ಗ್ರೂಪ್ ನಾವು ಹೆಂಗೆ ಚೆನ್ನಾಗಿದೆ
ಅಲೆಂಜರ್ಸ್ ಇದ್ರದ್ದು ಎಕ್ಸ್ರೇ ಇದರಲ್ಲಿ ಒಂದು ಅಲೆಂಜರ್ಸ್ ಸೀಮೆನ್ಸ್
ಹೌದಾ ಬಟ್ ಇದು ಆಲ್ಮೋಸ್ಟ್ ಇಂಡಿಯನ್
ಅಲೆಂಜರ್ಸ್ ಇಂಡಿಯನ್
ಹಾಂ
ಗುಜರಾತ್
ಅದೇ ಅದೇ ಈಗ ಸೋಲಿ ಇದಕ್ಕೆ ಕರ್ನಾಟಕಕ್ಕೆ ಬಂದಿದ್ದಾರೆ
ಬಟ್ ಜಿ ಅಂದರೆ ಜಾಸ್ತಿ ತೋರಿದ ಸೀಮೆನ್ಸ್ ಇಲ್ಲ ಜಿ ಜಾಸ್ತಿ ಇಲ್ಲ ಬಿ ಸಿ ಜಿ ಎಸ್ ಪಿ ಔಷಧಿ NIPT ಇದು ಕಂಪ್ಲೀಟ್ ಇದೆ ಒಂದು ಜಿ ಇದು ಜಿ ಇದು ಡ್ಯಾಶ್ 5000 ಅಂತೇಳಿ ಇದು ಜಿ ಇದೆ B20 ಮಾನಿಟರ್ ಅಂತೇಳಿ ಆಮೇಲೆ ಅಲ್ಲಿ ಅದು LNT ಮಾನಿಟರ್ ಲಾಸ್ಟ್ ಎಂಟರ್ ಇದೆ ಲಾಸ್ಟ್ ಒಂದಿದೆಯಲ್ಲ ಅದು ಫಿಲಿಪ್ಸ್ ಮಾನಿಟರ್ ಬಟ್ ಅದು 15 years ಓಲ್ಡ್ ಮಾನಿಟರ್ ಇನ್ನೊಂದು ವರ್ಕಿಂಗ್ ಇದೆ ನಾವು ಬೇಡ
Part of that program wanted to visit the hospital.
But this is second BSP motor. First hospital. BSP ಬರ್ತಾ ಇದೆ ಈಗ ಆರ್ಟ್ ರೇಟ್ ಓಕೆ ಆರ್ಟ್ ರೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಗೋದು ಇದು ನಾರ್ಮಲ್ ಇದೆಯಲ್ಲ ಅದನ್ನೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಗಿ ನಿಮಗೆ ಆರ್ಟ್ ರೇಟ್ ತೋರಿಸ್ತಾರೆ ಇಲ್ಲಿ ನಿಮ್ಗೆ ತೋರಿಸೋದು NIPT ಕಾರ್ಡಿನೈಸ್ ಇಲ್ಲಿ ನಿಮಗೆ ಟೆಂಪ್ರೇಚರ್ ತೋರಿಸುತ್ತೆ ಪೇಷಂಟ್ ಪ್ರೋಬ್ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ ಓಕೆ ಟೆಂಪ್ರೇಚರ್ ಇನ್ವೆಸ್ಟ್ ಅಂತಂದರೆ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ ಪೇಷಂಟ್ ಸಿಕ್ ಅಥವಾ ಫುಲ್ ಕ್ರಿಟಿಕಲ್ ಕಂಡೀಷನ್ ಇದ್ದರೆ ಅವಾಗ ಚೆಕ್ ಮಾಡ್ತಾರೆ ಅದು ಮೀನ್
ಬ್ಲಡ್ ಪ್ರೆಷರ್
ಆ್ಯಾವ್ರೇಜ್ 176/80 ಆ್ಯಾವ್ರೇಜ್ ಎಷ್ಟು ಆಮೇಲೆ ಇದು ನಿಮಗೆ ಸಿರಿಂಜ್ ಆ್ಯಕ್ಚುಲಿ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಒಂದು 20 ml 1 ಅವರಲ್ಲಿ 20 ml ಪೇಷಂಟಿಗೆ ಕೊಡಬೇಕಂತಿರುತ್ತೆ ಅಷ್ಟು ಬಂದು ಪದೇ ಇಂಜೆಕ್ಷನ್ ಕೊಡೋದು ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತಾರೆ ರಿಸೆಟ್ ಮಾಡ್ತಾರೆ 1 ಅವರಿಗೆ 20 ml ಅಂತ ಕೊಡುತ್ತೆ ಇದು 20 ml 1 ಅವರಿಗೆ ಕೊಡುತ್ತೆ ಕರೆಕ್ಟಾಗಿ ಅದು ಡಾಕ್ಟರ್ ಎಷ್ಟು ml ಅಷ್ಟು ಸ್ಲೋ ಆಗಿ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ನೀವು ಯಾವ ಕೊಡಬೇಕು 2 ml ಕೊಡಬೇಕಾದ್ರೆ 2 ml ಕೊಡಿದ್ದಾರೆ 2 ml ಕೊಡುತ್ತೆ
ಲೆವೆಲ್ ಯಾರ್ಯಾರು ರಿಸಲ್ಟ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ.
We cannot carry the ventilator and the patient to the X-ray part. So it's a mobile X-ray machine. Wherever it is required, to whichever bed it is required, we take the mobile X-ray machine and we'll take it. And this mobile X-ray machine will be here only in ICUs. It will not go anywhere. But wherever we want, we can just because the leads are there. Okay. And nowadays, digital X-ray machines are used, computerized. So first, they used to have a different X-ray machine, okay? And now they have a different X-ray machine. Now it is digitalized X-ray machines. First step of instrument. These are called as multi-channel monitors. These are called as multi-channel monitors. Okay. I think we can use it to see things. Sister, is we record saturation. Saturation ಅಂದ್ರೆ ಬ್ಲಡ್ ಒಳಗಡೆ ಆಕ್ಸಿಜನ್ ಕಂಟೆಂಟ್ ಎಷ್ಟಿದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ಯಾಚುರೇಷನ್. ದ ಆಕ್ಸಿಜನ್ ವಿಚ್ ಇಸ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ದ ಬ್ಲಡ್ ವಿಲ್ ಬಿ ಗಿವನ್ ಇಟ್ ಆಸ್ ಸ್ಯಾಚುರೇಷನ್. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ ಅಂತಂದರೆ ಇದರ ಪ್ರೋಬ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ as ಸ್ಯಾಚುರೇಷನ್ ಪ್ರೋಬ್. ಸ್ಯಾಚುರೇಷನ್ ಪ್ರೋಬ್ ಇದನ್ನ ಏನು ಮಾಡ್ತೀವಿ ಅಂತಂದರೆ ವಿ ಮೇಕ್ ದಿಸ್ ಟು ಕಮ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ ಟಿಶ್ಯೂ. ಮೋಸ್ಟ್ ಆಫ್ ದ ಟೈಮ್ ಇಟ್ ಇಸ್ ಫಿಂಗರ್. ಓಕೆ, ಇಲ್ಲೇನಿರುತ್ತೆ ಅಂದರೆ ಒಂದು ಲೈಟ್ ಎಮಿಟಿಂಗ್ ಡಯೋಡ್ ಇರ್ತದೆ. ಲೈಟ್ ಎಮಿಟಿಂಗ್ ಡಯೋಡ್, ಇಲ್ಲಿ ಒಂದು ಸೆನ್ಸಾರ್ ಇರ್ತದೆ. ಸೊ ದ ಲೈಟ್ ಎಮಿಟಿಂಗ್ ಡಯೋಡ್ ವಿಲ್ ಪಾಸ್. ಇದನ್ನು ಆನ್ ಮಾಡಪ್ಪ, ಇದು ವರ್ಕ್ ಆಗ್ತಿತ್ತು ಅಂದರೆ ಇದನ್ನು ಆನ್ ಮಾಡಿ. ಟಿಶ್ಯೂಸ್ ಒಳಗಡೆ ಏನಿರ್ತದೆ, ಬ್ಲಡ್ ಇರ್ತದೆ. blood again, okay, hemoglobin which is saturated with oxygen will have a different absorption of wavelength of the light. Hemoglobin that is not saturated with oxygen will have a different wavelength. So, ಅದನ್ನ ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ ಅದನ್ನು ಸೆನ್ಸ್ ಮಾಡಿ ಅದನ್ನು ಅದು ಸೆನ್ಸಾರಿಗೆ ಕಳಿಸುತ್ತೆ. So sensor will see which hemoglobin is saturated.
This is a radiant former, and now even in the almost all the government hospitals have probes or manually you can record and see to it that the baby maintains temperature between 36.5 to 37.5. It's a normal body temperature of the baby. So this bomber again is basically a Brazilian company made. So it has a lot of other extra options. So here we have, so this has you can connect oxygen here. If you connect it to the oxygen source and the flow meter, you can relate it to oxygen. Suction also, you connect it to the centralized suction source. You can use it for suction and then also for giving positive pressure ventilation. So when the babies don't breathe and you need to give them artificial breaths. So this, with the help of this, if it is connected to oxygen and gas source, you just have to connect the baby's mask here and put it over the baby and you can just give breaths to the baby. So that is the additional features that are there in this. Along with that, here you can put the X-ray plates. You don't have to disturb the baby. So this panel will just remove and put the X-ray plate here. The X-ray plate can be put here. So without disturbing the baby, the X-rays can be put. And apart from that, you have the
today's valedictorian Chief Guest Dr. P.S. Ravikumar to this valedictory function. I request Sri G.D. Vishnumurthy to welcome him. I'd like to welcome for well organizing and executing the program. Though one speaker unable to attend because of problem.
To this workshop, I happened to be here today and came at the end of the workshop. I did hear a lot of great things about the workshop. I did hear about a lot of good things that are done in this workshop. As my previous friends have said here, that it's not easy to organize a workshop like this. Okay. And in these days, it's also rare to find people who are of this age group to have a sustained, spirit of doing something out of their original, urge. There is a run-of-the-mill thing that happens every now and then. There are many places where I've seen that institutes are not by buildings, by lab and the infrastructure, it's for people. So I think it's good, it's great, and I have been fortunate enough to be in touch with Professor Holi.
before he came to this college and after he has come to this college and so on. I see that that spirit in him has helped many other faculty as well and the college as well and the
Director, Applied Cognition System, Bangalore. The coordinator of this faculty development program, Dr. Mallikarjun S. Kohli, the Department of Electronics and Instrumentation, Chairman, Department of Electronics and Instrumentation. Their invitees, chairmen and head of the departments of various disciplines, their faculty members, and the distinguished faculty members from various colleges as participants, and the volunteers. It gives me an immense pleasure to be a part of this function. At the outset, I congratulate the coordinator of S. Kohli and his team for successfully completing this 4 days workshop. From the feedback from the participants, Professor Jayadeva and Dr. S. B. Mallo, we have observed that this program has been organized systematically, efficiently, and effectively. You might have observed this voluntary function has been scheduled at 5:30. It has started exactly at 5:30. That shows the effectiveness and the punctuality maintained for running this 4 days faculty development program.
System, Dr. A. Manjunath, Professor, Civil Engineering Department and Principal in charge and President of this variety function, and all the participants and my dear colleagues. Indeed, it will be a time to say thanks to the many things. First of all, I place my gratitude and thanks to Dr. P.S. Ramkumar, who is kind enough to come here and to be the chief guest of today's valedictory function. On behalf of VTU, VGST, on behalf of Institute, Department, on behalf of all of you, I thank you, sir.